Hello, today's lecture is the review for exam 3. There are a total of 19 questions covered the materials from 4 chapters, chapter 12, chapter 14, chapter 15, and chapter 19. Just like exam 2, we will use proctoral through Blackboard for exam 3. The first topic involves questions from chapter 12. We used the chi-square test to test the equality of population parameters for more than 3 populations. Step number 1. State H0 versus H1. The pair of the hypotheses will be given. Step number 2, set up a table to find the test statistic chi-square. And we are going to use this equation to solve the problem. Chi-square is equal to the double sum of ij of Fij minus Eij square over Eij, where this Eij, the expected frequency, is given by this calculation. Row I total times column J total over total sample size. And here is the table. Fij is the given frequency or observed frequency from the sample result table. And Eij is the expected frequency calculated by this equation. And then we are going to compute Fij minus Eij square over Eij for each of the cells, and then we will sum them up to get the test statistic chi-square. Step number 3, we need to find the critical value chi-square alpha from the chi-square table with the degrees of freedom equals to k minus 1, where k is the number of proportions, or is the number of populations. And after you find the chi-square alpha, the critical value, we reject F0 if the test statistic is greater than or equal to the critical value on the right, because this is a right-tail test. And here's the table. And if your test statistic is more than your critical value on the right, you reject F0. If your test statistic is less than your critical value on the right, you fail to reject F0. Now, for chapter 14 is the simple linear regression model. Given the regression equation, y hat equal to b0 plus b1x, SST, SSR, and this sum of square with respect to x value is the sum of xi minus x bar square. And we need to answer some questions. And the most difficult problems involved the following 3 topics. One is how to find the test statistic, and the other 2 will be related to the confidence intervals. So let's look at the first one. To find the test statistic tcal, we need to have those 3 substeps. Substep number 1, you find the standard error of the estimate S, which is equal to square root of SSE over n minus 2. And we do not have SSE, but we have SST and SSR. So this S is equal to square root of SST minus SSR over n minus 2. Substep number 2, we need to find the standard deviation of the slope B1, which is equal to S over the square root of the sum of square with respect to x value. Make sure you take the square root of the sum of Si minus S bar square. And then sub-step number 3, the test statistic TCal is equal to B1 over SB1, where B1 is your slope. And this is how we find this TCal. Now, this 101 minus alpha % confidence interval for the true slope beta 1 is equal to B1 plus minus T sub alpha over 2 times SB1, and you can find SB1 from this previous calculation. And then this 101 minus alpha % confidence interval for the mean value of y is given by this equation, this y hat star plus minus the critical value times s, and again you can find s from this previous step, times the square root of 1 over n plus x star minus x bar square over sum of Si minus S bar square. And this S is a given value for the independent variable. Now, for this chapter 15 multiple regression model, I would like to mention the following. A, when we predict the value of y for the given value of independent variables, the unit is very important. 2, 101 minus alpha % confidence interval for the slope beta I is given by this bi plus or minus the critical value t of alpha over 2 times the standard deviation of the slope. So this is SBI, where P is the number of independent variables, and when we try to find the critical value, the degrees of freedom will be n minus P minus 1. So you need to use the T table, and then you find out alpha, you find alpha over 2, and the degrees of freedom will be n minus P minus 1. Again, P is the number of x's. Now, for chapter 19, I would like to mention the following. A, to determine if a process is in control or out of control, we need to consider 2 conditions. Condition number 1, all points are within the control limit. So for condition number 1, you locate the largest value, and this value had to be below your upper control limit, and you locate the smallest value from your data, and this value has to be above your lower control limit. For condition number 2, you look for an upward trend or a downward one. Okay. B, the X bar chart will have the center line X bar bar and the upper control limit of X bar bar plus A2 times R bar, and your lower control limit is equal to X bar bar minus A2 times R bar. For the R chart, your center line will be R bar, and your upper control limit will be R bar D4, and your lower control limit will be R bar D3. And there's one very important note. A2, D3, and D4 are based on the sample size n, based on n, from a table that is table 19.3. C, for the P chart, the proportion P, or the center line, is calculated by the total number of defects for your numerator and total number of samples for your denominator, which is S1 plus S2 all the way to Sk for your numerator, and denominator is n times k. And this equation is not given, so you do need to memorize it. Now, let's see some examples. And this first one on the list is a chi-square test. That's from quiz number 7. And I give you this sample result table, and I ask you to test the hypothesis. And step number 1 is given, so we start with step number 2. We set up this table to find the test statistic chi-square. So you have this Fij, which is the observed frequency or the given frequency. So you have 48, 19, 23, 52, 51, 47. And that's your Fij. And Eij is the expected frequency. So you have this location of 48, and you have subtotal of 90 and subtotal of 100. And so you have 90 times 100 over the grand total, 240, to give you the numerator. And this result is 37.5. And that's your Eij. Now, you have Fij minus Eij square over Eij. So you have 48 minus 37.5 square over 37.5. And that will give you 2.94. And let's see one more. So you have, for this 19, you have your subtotal of 90 and subtotal of 70 over grand total of 240. And that will give you 26.25. And your Fij minus Eij square over Eij will be 19 minus 26.25 square over 26.25. And that will give you 2.0024. So you calculate this Fij minus Eij square over Eij for each cell. And then you sum them up. And that will give you your test statistic chi-square equal to 8.552. Now, step number 3, make a decision. So for this case, you have K equals to 3. You have 3 proportions, or you say you have 3 populations. And that you have 3 minus 1, which is 2. And then alpha, I give you alpha for this example to be 0.025. So your critical value is chi-square 0.025. And look it up from your chi-square table, and you get 7.378. And you draw your number line and put 7.378 on your x-axis, and your test statistic is 8.552, which is more than your critical value on the right. You reject H0. Now, for quiz number 7, we have this 101 minus alpha percent confidence interval for the true slope beta 1 and the mean value of y for a given value of x. And those are the 2 equations we had mentioned. And to find this critical value, and we have alpha equal to 0.01 and n equals to 12, and the degrees of freedom is n minus 2, which is 10. And so that the critical value is t of 0.005 with degrees of freedom that is 10. So look it up from your t table. You will get this value 3.1693. And that's how you actually find your critical value. Now for chapter 15, and this quiz number 8, most of you did very well. I would just like to mention the following. 1, when we compute the predicted value of y for the given value of x, the units are very, very important. And for example, for this x2, and the unit was in percentage, and when I give you the value, it's 1.9%. So you have to use x2 equal to 1.9 because when you collect your data and the unit was in percentage. And also for this x3, and what we have is an indicator function. So when you have a standard car, this x3 is 1. B, when we do the interpretation of the slope bi, the statement holding constant the effect of all other independent variables is very important since we have more than one independent variable. Now, the statement associated with hypothesis testing is this. If we reject f0, then the corresponding independent variable is significant in explaining why and should be included in the model. Otherwise, it should not be included in the model. For example, if we are using the p-value method to solve the problem, then if the p-value is less than or equal to alpha, we reject f0, the corresponding independent variable is significant in explaining why and should be included in the model. If the p-value is greater than alpha, we fail to reject f0, then the corresponding independent variable is not significant in explaining why and should not be included in the model. Now, for chapter 19, quiz number 9, A2, D3, D4 are based on the sample size n. And for this quiz, I give you k equals to 10, and one form it was n equals to 4, and the other form was n equals to 6. So you have to use n, the sample size, to find A2, D3, and D4. Now for the P chart, I give you this set of data. So you have day 1, 2, 3, 4, 5, and sample size 200 for each of the days. And then you have the number of defects to be 41, 26, 32, 28, 39. And in this case, K is 5, N is 200, and the center line, this proportion P, is equal to total number of defects for your numerator and total number of samples for the denominator. So you have 41 plus 26 plus 32 plus 28 plus 39 for the numerator, and denominator is 5 times 200. So you get this 0.166. Now, for the upper control limit, is p plus 3 times p times 1 minus p over n, which is 0.166 plus 3 times the square root of 0.166 times 0.834 over 200, and that will give you 0.245. And the lower control limit is p minus 3 times square root of p times 1 minus p over n, which is 0.166 minus 3 times square root of 0.166 times 0.834 over 200. That will give you 0.087. Now, we need to determine whether or not the process is in control or out of control. So we will locate our largest value. In this case, is in day 1, and you need to convert this value into proportion. So you have 41 over 200 to give you 0.205, which is less than your upper control limit, 0.245. Now you locate your smallest value, which is 26, and now you have to convert this into proportion. So you have 26 over 200 to give you 0.13, which is above your lower control limit. That means condition number 1 is satisfied. All points are within the control limits. Now, condition number 2, we look for pattern, and this one is down, up, down, up. So there's no obvious pattern, and we said no pattern over time. So the process is in control. And this is the end of the review.